Yestermorrow Design Build School in Waitsfield, Vermont presents Doorways to Design, the 2015 Summer Lecture Series. Tonight, Top 10 Cold Climate Building Trends that Need to Become Systems with Eli Gould, founder of Ironwood Brand, developer of new construction assemblies and systems, and pioneer of some of the highest performing residential building projects in the region.
I'm going to do my top 10 list, kind of starting with a little bit of a diss. I don't really mean this, to set up straw dummies, but we all know that we are a very small group of people in a very small state in a very big country, that there's a lot of things going on in building that we don't really feel reassured by. And I think that poor planning is one of them for sure, and it's really, green building cannot stand in a vacuum. Even if you build a brilliant house, it's often sad when it's part of an overall transportation infrastructure system which doesn't work. We love our little New England clustered villages surrounded by open land. We're saddened by the waste that's out in the field, and we really are. We're well aware that the construction industry is not what, when you meet a young guy from Europe and he's proud of his traditions and he's trained and he has a mix of technical skills and everything else, and you compare who often goes into construction and why, and it really makes us realize that we need a better model. And the top 10 challenge that we all face is, even if we have great products, how can we hand them into poorly planned and poorly executed processes? That's a big challenge for all of us. And then the niche challenge, which is a double-edged sword that we love dearly, is we build exceptional houses for exceptional people. And how do you really translate that into knowing what things are going to cost and becoming more affordable? And how do we reconcile, even those of us who love a great envelope? I guess I'm going to point to this pie chart at the bottom, because it's something that I use to really talk about houses. To oftentimes a mainstream business person might end up building a very high performance home when they stand back for a minute and realize that all of their choices on the envelope may only add up to a third of their overall building. And a lot of the choices that drive their cost are really in that final 2/3 of finishes. And there's an increasing demographic, which we love, of smart people building smaller homes with much better bones. And I think that there's really a great business proposition for that. But it is tough to take these one-off projects and get that out into real-world costs. I don't know if we'll have a chance to do exterior cork insulation as we're doing in the upper right, but if we do, we know what it costs anyway. I think our biggest challenge that we face every day is that durability in Vermont, freeze, thaw, and moisture drive, is just an absolute threat to everything which we put out there. And even a really simple box that gets great numbers and looks like number one, this isn't our architecture, by the way, but it is something that looks like you have a chance of building it really simply. And yet, to make it durable, you're going to have a lot of layers. Just in this one picture here, we've got outboard insulation, we've got rain screen siding, we've got exterior extension jambs on windows that are draining to the outside. We've got a whole overframe cold roof, and our clients still worry, and we do too. When you look at that picture on the right, there was more chipboard in this one building than anything I'd ever built. And I'm kind of a native lumber guy, but I was going to engineer spec, and I was working with a really a concerned client, and he turned to me about halfway through and he said, I really don't like chipboard. And I looked at him and I said, you're like the guy 20 years ago who I got halfway through his straw bale house, and then he turned and said, you know that I have really bad hay fever. And so we all do worry about this, and we should worry. Structural is easy, but buildings are failing. High performance buildings are having trouble. everybody who's ever going to have a hand in the building should really educate themselves from now on about how moisture is going to work in that building assembly. And in Vermont, if you can solve that in Vermont with all the conditions we have, then you're going to be doing really well. So it's a great testing ground. The other challenge that I would like to highlight here, does everybody know what framing factor is? It's a percentage of actually, people talk about R value, I've got R50 insulation for my walls, but the framing factor is actually how much wood do you have in that wall, because your insulation's going in between it, and it's common for a tough, prickly energy planning engineer like a Mark Rosenbaum to say, well, yeah, there's high performance, but I expect most builders will probably build a wall that's about 20% wood at the best, and a lot of guys are doing 30% wood. And when you talk about advanced framing as the practice over the last 25 years to eliminate all those little extra double corners and jack studs and things that make solid wood thermal bridges, even a good advanced frame wall is probably a little less than 20%. And when you're called on to do passive house, as we did in this building here, we did a wall that actually had 7% wood, and was one of the reasons that we blew such good numbers on that home and why it's performing so exceptionally. But that's not really an easy thing to do, and I wouldn't do that without a great engineer with me, and Ben is, and he and I had been through this kind of job before, and when I recently brought a new architect to meet with him, and presumably everybody knows what a thermal bridge is. It's a place where wood goes all the way through a wall. And Ben knew that I was coming into his office with yet another passive house architect, and I was walking up the stairs, and he staged a shouting match with somebody on the phone that I don't even think was even there. And as we walked into the room, he said, yeah, well, it turns out all those things that you call thermal bridges are actually holding my building together. And he slammed the phone down there. He's like, oh, hi, guys. And the architect I was with didn't know his sense of humor. It was a little white-faced. But it's true. It's really hard to tune down a stick-built wall into small percentages of wood and still believe it in many ways. So the reason I'm showing this crane pick is that we engineered this wall as it's all I-joists, and then the small horizontal bands are basically a backing small batten. So every piece of sheathing has been glued and screwed, and all the tape on the outside is going to that. So the edge distances of all the plywood were so good on this that even though it's feather light, when we picked that, there was not a squeak. And that moment when you have a large section of building on a crane is when that's the toughest moment of service life for that wall at all. And so we know that these walls are tremendously strong, but it's not to be trifled with, really. And roofs are even worse because they have such a varied moisture and the challenges of roofs here we design typically to 70-pound snow load anyway, but how to build a really deep roof is a challenge because you're not going to get a 2x16. You're not going to get a 2x18. So this slide here may be a topic in and of itself, but once again, the simple moves to get the framing factor low involve things like the guy up on the ridge beam on the right-hand side. We're just borrowing from our timber frame background. Timber framers are good at putting structure on the inside. That's always a good idea for us. Less thermal bridges when it goes to the outside. Put a ridge beam in down below it. Don't let any engineers put some big ridge beam up in that top. And then we're using an engineered floor joist out of Canada that's pretty unique with no metal connectors and all solid wood. No chipboard and no plantation grown wood, and we really love all that, and you can get a 16-inch deep and do a bunch of different ventilation and insulation strategies in it. But We're actually really conservative, and we think about what we're going to do pretty carefully, and we try and, even though we're known for doing new stuff, we probably would have been getting in a lot more trouble if we hadn't been fundamentally pretty conservative. And I guess my cold climate challenge number 5 is that people who build high-performance homes like to talk numbers with each other, and I don't mind that, but I have to stay pretty neutral on what systems I like, or what, because I like to build anything that somebody, what I love about any standards is that they elevate people's craft, and it's great to be part of those jobs, but it doesn't come down to numbers, and there's some things that numbers really don't describe. The durability of materials, the health of them, or really the increasing commitment I've seen among many of my clientele to want to build a building which is foam free, and I respect that. That's not all we practice, but when we do, for instance, Alex Wilson's project used a material that had only rarely been used for residential insulation. It's a cellular glass. It's called foam glass. It's made in the USA and has been here for quite a while, lining blast furnaces. It's stable up to 1900 degrees. Termites can't touch it. Pretty awesome product. Expensive, but Alex who has spoken out against the foam and petrochemical industries for so long, really just said, in a leadership project like this, Eli, I can't do it. But then when we worked with Ardex, made by Pittsburgh, worked with foam glass made by Pittsburgh Corning, and we asked them, well, how do we stick this to the foundation? They had a completely toxic naphthalene tar that we were supposed to smear on, and it was going to cost another $3,000, and Alex didn't want it in his groundwater, or my guys getting tangled up in it. And he turned to me and said, here's a system development thing, but we got to do better than that. What do you think we can do? And my son was about 7 or 8 at the time, and he's been around job sites with me a lot, and we've seen one of the biggest changes in terms of material change out there right now. I actually think that polymer cements are right up there with the things that have changed the way buildings happen. I mean, people are now hanging thin slices of marble on skyscrapers. We're doing stone veneer. We're sticking stuff with polymer cements, which are a pretty benign thing, really. And they've changed what can happen. So we basically knew a bunch of cementitious products that we wanted to try. We bought a bunch of them, stuck them all together, did some field trials. We liked what we saw with a few of them, and found out they were made by a company which used to be in Vermont, but now is part of a European subsidiary. And it's Ardex. And we called both companies and said, hey, we're going to try a cementitious, polymer reinforced cementitious system for your 2 lines. And both of them were like, wow, you're going to do what? That is pretty cool. And they put senior product guys on planes, and they helped us launch this. And we said to them, we're not looking for intellectual property or patents, but you're both good companies, and you ought to be working together. And to my knowledge, they still are, and they're sending me field results. We did the first of it. I've become a little bit of a foam glass hotline, which is a strange, sort of outwash. So other people who want to do it now, knowing that the system isn't out there yet, sometimes call me, usually late at night when they're worried about what's going to happen the next day. But we were, again, really conservative with this. We mechanically fastened everything twice, and the foam glass is a great product, and it represents a type of material that I think a lot of people care about. We wish we could afford. I wish foam glass was moving into this market in a more concerted fashion, but we'll see how they do.
How does foam glass work?
It's brittle. It's like if you had it looks, feels, and smells like a piece of volcanic pumice. So like if you scratch it, there's a release of some sulfur, which was part of its actual binding agent.
So it's glass that they...
It's a cellular glass that it's basically like small glass air-filled bubbles that are fused together in a brittle, lightweight block that you can get in different thicknesses.
And the like blowing agent is?
It's a I would have to defer to Alex on this, but it's a sulfurous compound. You can smell it when you scratch it, which besides its odor is a non-toxic thing, and it's very brittle. You can see some of the tools I used. I did a job site table saw with a stone blade in it, and that did fine. I also had just a small jigsaw with a carbide tipped, like tile cutting thing to cut sewer inlets and outlets. Even a wallboard saw does pretty well with it. Not a lot of fun to work with. There's like basically black glassy powder that gets into your collar, but really in many ways, foam's not a lot of fun to work with, and this stuff is going to be here a long time. And we knew that even though this is experimental, it's a really durable product. And we did things like, you can see my guys here are on the deck, and we ran our foam glass up onto the rim board. It does have a lower R value per inch than foam, as do many natural. And when we get into cork up above it, we really had to make choices on this building to go with really thick layers to get to his energy goal. That would have been easier with foam, it would have been thinner. So like a lot of other natural systems, you want to build it in from the footing right up, and that's essentially what we did here. We had the whole thing on a really wide footing, and so even though you can see one of my workers sticking it to the wall there, we weren't relying on it. We weren't hanging it on the wall. We were just sticking it to it and stacking. I think where Alex really drew the line for himself, which was interesting for me to watch, is that what we do know about this are what it's made of, and I think I actually have I have many clients who have made a business decision, which I respect, that does involve foam, and I'm fine with that in my buildings. But on health, I'm a little uncompromising, as is Alex, and I think Alex has been right about some things before, and what he said about foam over and over is that you can argue, yes or no on it, but the brominate, like the fact that it's so flammable, and then what they add to it, to reduce its flammability in terms of brominated families of I'm going to get my chemistry wrong, but the additives to foam are his deepest concern, and that the foam industry may not using those inside of a building. So I basically, when I use foam, I use it on the outside of a foundation or on the outboard wall, and I don't like to see people putting it right into their living spaces if at all possible. But I think there's a fair argument to be made on that for sure. But it's interesting when you see his next choice. It's pretty hard to be perfect, because you can have cork, you can have naturally derived cork, but if it came over on a boat, which ours did, and then had a dock strike, and then had to circle New York during Hurricane Sandy, then we're just thinking about all the fuel that it took to get the cork here. So I think my main point here is that we're proud of our foam-free stuff, but we're not really prejudiced in our others. We love this cork product. It was pretty cool. We were maybe one of the first in North America to really get our hands on it. And well, that's not true. We're the first to do a modern wood-framed building with it. It's been around for a long time and has been, even Armstrong Industries used to be Armstrong Cork, and this was a process to make this cork, which I can get into if people are interested. It's a process which was patented back in the 1890s. So you'll see old apple coolers and other things in Vermont from the pre-insulation era, which are actually lined with cork. It was used for life boat flotation on ships like the Titanic. So it's been around for a long time as a material, and that was pretty awesome. So I imagine the natural building, I'm not sure how many slides I have on it.
What were you using the cork for?
We used it as outboard insulation over our foam glass. We used 6-inch blocks of it on the outside of this whole farmhouse as a naturally derived and vapor open and insulating material. This is not, when they make cork, obviously it's a bark product, and they take a slice of it, and it's been harvested in from the same trees, many of them being centuries old. So it's a renewable product that has a byproduct. When they make corks and punch out all the wine corks, there's like a sheet which is left with all the negatives of that. And by accident, somebody discovered in the 1890s that a combination of high pressure steam will release, it's sort of like popcorn. It'll make it expand, and it'll actually release all the lignins in that, and it'll rebind itself with no binder. So they make this basically huge billet and then saw it into whatever you need. And we actually got it shiplapped. So when we did our 6-inch, instead of, it was pretty efficient. Instead of, when we've wrapped buildings with, let's say polyiso, we're going around that building a bunch of times. Here's like just a big friendly brick, which you're setting along. And in Europe, they use these billets up to 10 inches thick. Most of their details are to go on the inside or outside of masonry structures. So they had no wood framing details. And I am hoping I'll have some more slides in it, because we loved using it. We were actually pulling old 2-man saws out of the barn and cutting it with that, which worked really well. And people asked us, well, what about bugs and what about fire? And I said, well, can you really with a straight face handle foam and not ask those same questions? What about bugs and what about fire? I mean, this stuff, number one, at the high pressure, it has a really smoky smell, and we all know from from traditional practice that when the settlers were hanging their seeds in the smoke to keep the bug, that was like a natural insect repellent, and certainly insects love foam, and it's way more fire resistant than any foam I've ever seen, and it's amazing on sound. It's just heavy. It's surprisingly heavy, so you don't want to take it lightly. We were glad we were going all the way to the footings with all of our details, but in the meantime, when we're building for people on a different budget, we're really dialed in on essentially on the right-hand side, you can see a double stud wall, and we have some details at our window if you see in the middle. Using what we learned about I-joists only for the windows gives us a chance to make a really strong window opening and essentially carry our windows when they often exist outboard of our foundation. We really love that they're carried really firmly. And we also love I don't know if it's clear, but the white portion in this is our interior trim. And having that big, deep, wide windowsill and that castle wall feeling is kind of a nice thing too. So. And that's a wall that can be filled with cellulose. It can even be spray foamed on the outside, and then services can be run. It could be filled with a whole bunch of different things, but it goes up in ways that look and feel a lot like carpentry. We can flat pack it, we can panelize it, or we can build it all. But outboard insulation, just so everybody's familiar, I mean, obviously codes and practice are trending towards this. It's clear from everybody involved, you're going to get better insulation value with one continuous membrane like on the outside. If it's an assembly that you can demonstrate, that you can dry out, I think that's a good thing. We take no part in impermeable foams on the outside of buildings and trapping that. We like to have our air barrier on the inside and then have a drying potential to the outside. But it's because we have to deal with all of our own siding and details and have discriminating clients, we can't just hand that off to somebody else. And to really hang siding on the outside of a building well takes a bunch of details. If you see the picture on the left here, it looks nice, but when I see it, I'm like, well, we had to saw our own strapping at full 1 inch out of hemlock because we're putting a long screw through that, and when you countersink a screw into a little tiny piece of strapping, there's nothing left. So we saw our own strapping, it's super wide, we have to deal with, and so we believe in it from a building science point of view, but we've had to like set the price pretty high because we know what it costs to do it really well, and it's not worth doing it if you can't do it well. So it's a big trend right now, and it's tough to make it into a system. It's tough when something is reliant on wrapping a building multiple times, and you have good carpenters who you're paying well. You just look at that like, oh no, if I can't get some of that into the shop, it's just going to cost more and more. So we would go so far as if we were on a job that we knew was driven by outboard insulation, we'd probably modularize our corners so we could get our corners all built and then go from there. There needs to be some better ways to do this well. And we've tried that. We've tried an outboard insulation or an outboard window surround system that we could build inside that would have all the flashing layers, all the metal, and the right flaps of house wrap so that basically a lower skilled siding crew would be able to show up with siding tools and actually do a good deep energy retrofit. We do think outboard insulation is really compelling because we live in New England and all the best pieces of land have beautiful homes on them, and those homes are often energy pigs. We want to see them fixed. There's people in those homes. There's usually nice windows on the inside, and it would be great to say we have a really affordable way to strip your siding right off. Let's get the lead out of here. You can stay inside, leave your walls alone, leave your plaster, leave your outlets where they are, and everybody's first question is, well, that's good, but what about the windows? And we'd love to say you don't need to have a vinyl window come in here. Keep your old windows, tune them up, get some new sash weights, and let's come in with an exterior storm and the window surround system. We call ours WindowPLUS, and then we'll pre-make all those in a shop, and that good guy down the road who does siding can actually run a product right around the outside and then side it. And I think there's a lot of products that would work well with that. I'm not wedded to cork. I think there's newer products coming along. I like a lot of the mineral wools for that. I think maybe we might hear from Tom and Emily about some other product ideas. But the main thing that we do is we take that really tricky high craft intersection and try and get that at least a little more systematic. And we've got this piece down to, we have these frames down to 28 pieces. Our first European windows were 38 and they were up on a scaffolding. So we feel like we're getting somewhere, but it takes a while. I think cold climate challenge number 7 is that there's a lot of people talking about passive house. There's a lot of people talking about I forget the Efficiency Vermont program, which is modeled after passive house, but we're in Vermont, and ground heat transfer is not a simple science, and it's not always a bad thing. So to me, any system that says you need 6 inches of insulation or you need to disassociate yourself from any ground heat, I kind of call bullshit on that, because I've seen a real engineer calculating that carefully, and the questions are about what kind of soil, how wet's that soil, how deep are you under it, what's the soil temperature, what are you doing at the edges is often more important. And I have a lot of buildings out there. Some of them are really extremely separated from ground heat and some of them are not, and I've noticed some things that make me feel like it's not always a bad thing. So we would never follow a rating system or anything prescriptive when it comes to ground heat transfer in Vermont, because honestly we're also living in a place where a lot of the flat ground has been built on, and we love to build with walkouts and build into the hills, and those are situations where you have to look at that site really carefully and get it right and put the insulation where it matters the most, and in other parts of that same building, you might very well be seeing a little bit of ground heat transfer as a good thing. So I think challenge number 8 is that mechanical systems there was no HVAC system, and now there's a few, and they're great. Everybody loves a mini split. They're flying off the shelves. Everybody's buying them, and I love air source heat pumps. I love heat pumps in general, but I'm really worried that mini splits are an early adopted. I don't want to say fad, because they're definitely here to stay, but it's only one version of what should be out there heat pump wise, and I think we all love it so much because it's a system. It'll do what it says it's going to do out of the box, whereas when you call a ductwork guy or you drill a geothermal well, you're relying on a lot of engineering, a lot of variables, and it may or may not work as you want. So I think we all want for our heating, ventilation, and air conditioning to work like a system, but I don't think mini splits are the answer to all of it yet, and I'm really pushing, because I have some contacts at Mitsubishi, and you know, they sponsored at Wilson's and used us in some advertising and proved, I mean, it's pretty impressive when you look at that farmhouse, and on the outside there's one little air source, one little outside unit, and on the inside at the center of the frame, that little 18,000 BTU head is the sole source of heat for the building, although he has a stove that he can use in super cold weather. It's doing it completely with that. We sized it for that. We built an envelope that was designed so he could use that size heating unit, and that all works great. But what about hot water? And what about the fact that you're not really, in the winter, how are you making hot water? And we crossed a line 6 or 7 years ago where most of our buildings started being at a point where the largest load was hot water. So it's not going away. We are all American. We take hot showers, and it's nice to have. So I don't think mini splits have it all yet. And I'm pushing Mitsubishi pretty hard to bring air to water. So that same outside unit, instead of heating instead of an inside head, which is just one small point source of heat, which may not solve what you're doing in your old New England home, then we need to get air to water, because we're pretty good at moving heat through water in New England. Our plumbers are all hydronic guys. We have baseboard through all of our houses, and we like to have small rooms and closed doors. And frankly, we need to make hot water for our lifestyles. So I'm really pushing for more of a full line of air source heat pumps like they have in Europe and Canada. And I hope everybody, I hope that people who are buying these are ready to upgrade or think about whether it's the right solution right now. I don't know if we want to get into it or not either, but as we've incentivized heat pumps, I think Vermont this coming winter could get one of its first wintertime peak loads in a long time. So Green Mountain Power, who is a very progressive and cool, nationally recognized utility, is going to say to Efficiency Vermont, who's also a great organization, like, all right, that was all fun and games until just about everybody bought one of these things, and now we have a wintertime spike in our power. And that's my other concern about air to air, is that you're calling for the heat right when you need it. So if you think there's this friendly fantasy out there right now, I've got solar panels, I've got a heat pump, and I'm net zero, but that doesn't translate to the grid at all. You're actually running a system that's putting power onto the grid when it might not need it, and when everybody's calling for heat at 4 in the morning, and it's all air to air. Those are some big electric units kicking on. And on a grid level, planning level, it's pretty poor planning. And I think if we had the air to water, we could make heat while the sun was shining, and have it in a storage tank. And when you called for heat, you could be circulating using a very small pump. So it's all just basic, to me it's like basic, why aren't we planning for more of this? Why, and are we really going to let our grid, like have major problems with two good organizations not working well together? Challenge number 9, I think, indoor air quality. We have to get back to why we build great buildings, and it's so we can breathe good air and be in good spaces. And it's amazing how many really tight buildings aren't taking this seriously, and really how many great systems even are prone to some problems. So we like to monitor indoor air and have that be part of it, not just have something running all the time. And we basically, we have to admit that since there's no HVAC systems, we're out in front trying stuff. And you can see some pictures here of things like me in the middle showing a retrofit where we're building. This was a house that we tightened up to the point where we needed ventilation air, and we had to build a bunch of timber-like elements which actually had ductwork in them. We use heat pump hot water heaters a lot. You can see in the upper right and in the lower right, we're very well aware in our buildings that a heat pump hot water heater is like having a mini air conditioner and a dehumidifier. We see that as a good thing, and the fact that you're using the waste heat from your building to make hot water, something we're doing a lot of work on. They are making cold air, and that's why people who do a mini split and a heat pump hot water heater and then walk away, I think, are fooling themselves. We use them, and we use them in the summer only. We actually turn them right off in the winter. And bringing me to my last point that we still like to burn stuff. We're sort of old-fashioned that way. And my client, whom I was building a passive house for, on the left, she had a passive house blog. She had a lot of followers, and she did like an April Fool's prank of a chimney burning stuff in her house, and she got a little flutter out of all of her followers. Well, we're not really like that. We love a lot of hot water, and we love to have a fire in our homes personally. And my little guy and I splitting wood here, like basically. I hope there's a future that still has that in it. We love hydronic stoves. We love small wood boilers, and I don't think that's going away. So in the homes we like to build, we're not burning oil all summer because the heat pump hot water heater is running. We don't need an air conditioner because we have that cooling happening, and then we shut it right off. And we're not burning oil in the winter because we have a hydronic wood stove going then. So that doesn't comply with anybody's real. That certainly won't meet passive house, but that's something we love, and it's something that to get to major hot water loads, it's still probably good to plan on burning something for now. But our top 10 challenge here goes to number 11. We really like to take, now that we've been at this for long enough and we see our small community becoming a source of leadership for the mainstream, I think it's all on us now to really bring what we're learning and practicing out to a broader audience. Certainly in southern Vermont, we are building for a wider range of southern New England, and we're not just building for our own market. You can see here in these pictures, blue-collar guys with heavy timber, working for a client hanging an American flag on their barn, and we're actually, in this case, while we were prefabbing elsewhere, we wanted to build a small section of this building so we'd have a staging area. So we sent everything up there as a kit, and it just looks like a stick frame going together. You wouldn't even know standing back that actually would qualify for passive house. And that same building on the right, super deep stud walls, but made of all native lumber and built by a whole bunch of guys who really didn't even come out of high school thinking this was ever going to be something they were going to be known as a team doing super high quality buildings. So it can be done. It takes a lot of work to keep it mainstream. We're pretty proud of that. We think this is a great organization here, that you guys are all learning some really cool stuff. And our main urge is that we all as a community reach out to the broader world and show them what we're doing. Yeah, thanks for coming out, everybody. I'm gonna stop talking now.